Welcome to Design of Machine Members 1. In this lecture, the topics covered are Introduction to the Design, Basic Procedure, Basic Requirements of Machine Elements, Design of Machine Elements, Traditional Design Methods, Design Synthesis, Standards in Design, Preferred Numbers. Let us start with a quote. If the point of contact between the product and people becomes a point of friction, then the industrial designer has failed. On the other hand, if the people are made safer, more efficient, more comfortable, or just plain happier by contact with the product, then the designer has succeeded. Henry Dreyfus. He designed a refrigerator for General Electric, alarm clocks for Westclox, vacuum cleaners for Hoover, J3 Hudson locomotive, a round thermostat for Honeywell, tractors for John Deere, and many other additional products designed by Henry Dreyfus, an industrial designer from United States of America. Machine design is the creation of new and better machines and improving the existing ones. A new or better machine is the one which is more economical in the overall cost of production as well as in the operation. The process of design is a long and time consuming one. From the study of existing ideas, a new idea has to be conceived. The idea is then studied, keeping in mind its commercial success, and given the shape and form must be taken of the availability of resources in money, men, and materials required for the successful completion of the new idea into an actual reality. In designing a machine component, it is necessary to have good knowledge of subjects like mathematics, engineering mechanics, strength of materials, theory of machines, workshop processes, and engineering drawing. A designer uses the principles of the basic engineering sciences. Some of the examples are Newton's laws of motion, D'Alembert's principle, Boyle's and Charles' laws of gases, Carnot cycle, Bernoulli's principle, so on and so forth. The designer has technical information of the basic elements of a machine. These elements include fastening devices, chains, belts and gear drives, bearings, oil seals, gaskets, springs, shafts, keys, couplings, so on and so forth. A machine is a combination of these basic elements. The designer should know the relative advantages and disadvantages of these basic elements and their suitability in different applications. The designer uses his skill and imagination to produce a configuration, which is a combination of these basic elements. However, this combination is unique and different in different situations. The intellectual part of constructing a proper configuration is creative in nature. The final outcome of the design process consists of the description of the machine. The description is in the form of drawings of assembly and individual components. A design is created to satisfy a recognized need of customer. The need may be to perform a specific function with maximum economy and efficiency. Basic procedure of machine design. Here in this flow chart, you can see starting with the market survey, then specifications of the product are defined, and then study the alternative mechanisms for the product and selection of the proper mechanism, and then preparation of the general layout and selection of various joining methods between individual components of the product, and then design of individual components, and then prepare the assembly and detailed drawings and modified drawings after testing the prototype model. Let us discuss these things in detail. Product specification. The first step consists of preparing a complete list of requirements of the product. For example, if we want to design a scooter, the following specifications are required. Let us say it should have a fuel consumption of minimum 40 kilometers per liter. That means the fuel economy should be more than 40 kilometers per liter, and maximum speed, that is minimum 85 kilometers per hour. Carrying capacity 2 persons with 10 kg of baggage or luggage. So 2 persons, these days average persons minimum 60 to 70 kgs. So that is 150 plus another 10 luggage. 160 is the carrying capacity. Overall dimensions, width, height, etc. And the self weight of the vehicle, it's around 95 to 100 kg. The cost of the vehicle, so let us say 40 to 50,000. So like that, while uh, planning, the first and foremost thing is to list out the attributes we would like to have in that particular product. And then next thing, selection of mechanism. For a particular product, we need to select the suitable mechanisms for the transmission of power and conversion of energy, etc. After careful study of the requirements, the designer prepares rough sketches of different possible mechanisms for the product. For example, while designing a blanking or piercing operation, the following mechanisms are possible. 1. A mechanism involves a crank and connecting rod converting rotary motion of the electric motor into reciprocating motor of the punch. So, electric motor rotates and which is converted into the reciprocatory motion of the punch. Depending upon the cost competitiveness, availability of raw materials and manufacturing facility, the best possible mechanism is selected for the product. So here there might be several such mechanisms which can be used for the particular application, but based on the cost competitiveness, based on the energy efficiency, and based on the availability of the raw materials and manufacturing capacities, we are going to choose a particular mechanism. Next, layout of configuration. The next step in the design procedure is to prepare a block diagram showing the general layout of the selected configuration. For example, the layout of a EOT, electrically operated overhead traveling crane, EOT crane, consists of the following components. Number one, electric motor for the power supply, flexible coupling to connect motor shaft to the clutch shaft, clutch to connect or disconnect the electric motor at the will of the operator, gearbox to reduce speed from 1440 rpm at the motor to about 15 or 20 rpm for the motion of the things on the EOT, rope drum to convert rotary motion of the shaft into linear motion of the wire rope and pulley with the crane hook to attach the loads. So loads are attached and they must be lifted up and they moved in the horizontal direction on the crane. Uh, Brake to stop the motion. So there must be brake. So it started moving, and if you want to stop it somewhere and place it down for the further operation, you have to apply the brake. There should be brake. In this step, the designer specifies the joining methods such as riveting, bolting, or welding to connect the individual components. So these individual components, they should be connected with one another. Uh, it might be due by different fastening operations. Rough sketches of the shapes of the individual parts are prepared. Design of individual components. The design of individual components or machine elements is an important step in the design process. It consists of different forces acting on the component, selection of proper material for the component based on requirements such as strength, rigidity, hardness, wear resistance, so on. Determination of the failure mode. So the component, depending upon the load supplied, it may be subjected to some kind of failure. Depending upon the mode of failure, we are going to uh, select the criteria of failure. It may be yield strength for ductile material and ultimate tensile strength for the brittle material, endurance limit for fatigue loading conditions, a permissible deflection for members like shafts which are mounted with gear wheels, where the contact between the two such gears which are mounted on the parallel shafts is very very important. Next, determination of the geometric dimensions of the component using a suitable factor of safety and modify the dimensions from assembly and manufacturing consideration. This stage involves detailed stress and deflection analysis. Next, preparation of the drawings. The last stage in a design process is to prepare the drawings of the assembly as well as individual components. On these drawings, the material of the components, dimensions, tolerances, surface finish grades, machining symbols all are specified. The designer prepares two separate list of components. Number one, standard components to be purchased directly from the market, and special components which are to be machined or manufactured in the factory itself. In many cases, a prototype model is prepared for the product and thoroughly tested before finalizing the assembly drawings. It is seen that the process of machine design involves a systematic approach from known specifications to unknown solutions. Quite often, the problems arise on the shop floor during the production stage, and a design may require modifications. In such circumstances, the designer has to consult the manufacturing team and manufacturing engineer to find out the suitable modification. Next, basic requirements of machine elements. A machine consists of different elements. Each part of a machine which has motion with respect to some other part is called as machine element. It is important to note that each machine element may consist of several parts which are manufactured separately. For example, a rolling contact bearing in a machine element consists of an inner race, outer race, cage, rolling elements like balls or rollers, etc. These are all the individual elements that together it is a ball bearing or a roller bearing. A machine element can be classified into two groups. First one general purpose and second one is special purpose. General purpose machine elements includes shafts, couplings, clutches, bearings, springs, gears and machine frames. Special purpose machine elements includes piston, valves, spindles. Special purpose machine elements are used only in certain types of applications, whereas general purpose machine elements are used in large number of machines. Strength. A machine part should not fail under the effect of forces that are acting upon it. It should have sufficient strength to avoid failure either due to fracture or due to yielding. A member which might be a ductile material or a brittle material, and when it is subjected to a force or set of forces, it should not fail. If it is failed by yielding, if it is failed by yielding, then the material can be termed as a ductile material. The ductile materials fail by yielding. What happens when they yield? When they yield, the contact between the adjacent components or the contact between the successive components is lost. When it is lost, the sole purpose of the machine or the particular mechanism is lost. So therefore, strength is not just the separation of a part into two, it is the amount of force that is needed for the member to make it ineffective. If it is effective, that means it is within the limits. It is deforming or it is enlarging within the elastic limits. Next, rigidity. A machine component should be rigid, that is, it should not deflect or bend too much due to forces or moments that acts on it. A transmission shaft many times designed on the basis of lateral and torsional rigidity. In these cases, maximum permissible deflection and permissible angle of twist are the criteria for design. So rigidity is important for especially shafts. When a shaft is deflected, then it is going to lose the contact with the, that means the gears which are mounted on the shaft, they are going to lose contact with the gears on the parallel shaft, and the angle of twist is also very important. So the amount of twist a member can go through due to the application of the force should be minimum. So when it is minimum, we call the member is to be rigid. If the member is going through a lot of angle of twist with the application of a simple force, then we call the member as a less rigid. Next, wear resistance. Wear is the main reason for putting the machine part out of order. It reduces the useful life of the component. Wear also leads to loss of accuracy of the machine tools. There are different types of wears such as abrasive wear, corrosive wear, pitting. Surface hardening can increase the wear resistance of machine components such as gears and cams. So wear resistance is also one of the important attributes for the machine element, because when two machine elements are in relative motion, and there will be friction and there will be wear. If the wear is going to happen at a higher rate, then what is going to happen? Within short period of time, the contact between them, that means the fastening between them, will be lost. That means the fit will be converted into loose fit. When they are loose, the relative motion between them is hampered and sometimes the parts may get separated. Next, minimum dimensions and weight. A machine part should be sufficiently strong, rigid, wear resistant, and at the same time the minimum possible dimensions and weight. So here it should have all the above three. Strength wise it should be good, rigidity wise it should be good, and according to wear resistance also it should be good. But along with all the three, the minimum dimensions and also the weight. So weight should be minimum and the dimensions should also be minimum. When we have these things, weight and dimensions minimum, the part is going to occupy very little space. It is very compact and also it costs very less. Next, manufacturability. It is the ease of fabrication and assembly. The shape and the material of the machine part should be selected in such a way that it can be produced with minimum labor cost. Next, safety. The shape and dimensions of machine parts should ensure safety to the operator of the machine. The designer should assume the worst possible conditions and apply uh, fail-safe or redundancy principles in such cases. Next, conformance to the standards. A machine part should conform to the national and international standards covering its profile, dimensions, grade, and materials. Reliability. Reliability is the probability that a machine part is going to perform its intended functions under the desired operating conditions over a specified period of time. A machine part should be reliable, that is, it should perform its function satisfactorily over its lifetime. Next, maintainability. A machine part should be maintainable, and maintainability is the ease with which the machine part can be serviced or repaired. Next, minimum life cycle cost. The life cycle cost of the machine part is the total cost to be paid by the purchaser for purchasing the part, operating it, and maintaining it over its lifespan. Over its lifespan, how much you are going to pay first for the purchase, second to operate, and third to maintain it. So the sum of all these is the minimum life cycle cost. It should be minimum. Next, design of machine elements. Here in the flow chart, the first thing is we are going to specify the functions of the element. Next, we are going to determine what are the forces acting on it and select the suitable material for the element. We are going to determine the failure mode. Depending upon the failure mode, we are going to find out the dimensions of the member in order to prevent that failure, and then assembly, manufacture, the dimensions are modified, and checking the design at critical cross sections, and finally preparing the working drawing of the element. Step 1, specifications of function. The design of machine element begins with the specification of functions of the element. The functions of some machine elements are as follows. Number 1, if you take a bearing, it is to support a rotating shaft and confine its motion. A key is to transmit the torque between the shaft and adjoining machine parts, maybe a gear, maybe a pulley, or maybe a sprocket. The purpose of the key is to transmit the power between the shaft and things that are mounted on the shaft. Next, spring in a clock. So what the spring does in a clock? It is going to store the energy and release the energy. Next, spring in a spring balance. It is to measure the force. Next, screw fastening. It is going to hold two or more machine parts together. Next, a power screw. The purpose of the power screw is to produce uniform and slow motion to transmit the force. Step 2. Determination of forces. In many cases, a free body diagram of forces is constructed to determine the forces acting on different parts of the machine. The external and internal forces that acts on the machine element are as follows. Number one, the external force due to energy, power, or torque transmitted by the machine part are often called useful load. Next, static force due to dead weight of the machine part. Number three, force due to frictional resistance. And the next one, inertia force due to change in linear or angular velocity. Next, centrifugal force due to change in direction of the velocity. And next, force due to thermal gradient or variation of the temperature. And next, force set up during the manufacturing of a part resulting in residual stresses. And next, force due to a particular shape of a part such as stress concentration due to abrupt change in the cross section. For every machine element, all forces in this list may not be applicable. Some of them are applicable, some of them are might not be applicable. They vary depending upon the application. Depending upon the application, some of them are applicable. There is one more important consideration. The force acting on the machine part is either assumed to be concentrated at one point or distributed over the particular area. Experience is essential to make such assumptions in the analysis of forces. Next, selection of material. Four basic factors which are considered in selecting the material. Number one, availability. Number two, cost. Number three, mechanical properties. And number four, manufacturing considerations. So these are the four factors for consideration of the material selection. For example, if you take a flywheel, or if you take a gearbox housing, or if you take a engine block. So all these are having some complex shapes. These components can be easily made by cast iron because the casting process produces complicated shapes without involving the machining operations. If you take a transmission shaft, these are made by plain carbon steels because they are available in the form of rods besides their higher strength. The automobile body and hood made of low carbon steels because of the cold formability. They can be formed and with the cold working conditions. Next, free cutting steels. They have excellent machinability due to addition of sulfur. They are ideally suitable for bolts, studs because of the ease with which the thread profiles can be machined. And a crankshaft and connecting rod are subjected to fluctuating forces. Nickel and chromium steels are used for these components due to the higher fatigue strength. Next step, failure criteria. Before finding out the dimensions, it is necessary to know the type of failure the component may fail when it is put into service. The machine component is said to have failed when it is unable to perform its intended function satisfactorily. There might be three basic types of failures. One,